Welcome back to our second lesson on grade 12 financial mathematics. In the first lesson, we discussed how to calculate N when we are dealing with compound interest or compound depreciation. In this lesson, we're going to start with annuities. The first annuity we're going to discuss is the future value annuity. Now, in future value annuities, it is really important for you to realize that if we make monthly payments, and take note, it must be equal monthly payments. So when we make monthly payments over a period of time, it doesn't matter for how long, it can be for retirement purposes, to save for a holiday or for education, then we want to calculate what the value of those payments will be after 5 or 10 or 20 years. So before we look at the first example, let's just quickly discuss the formula that we're going to use for future value annuities. You will notice that I've said here that a future value of an annuity is defined as the collective value of all the payments, including interest, immediately after the last payment. So it's imperative for you to remember that future value goes always together with the last payment. This is the formula that we're going to use for future value annuities. F for future value, X, that is your monthly payment, 1 plus I to the n minus 1 over I. Please take note that n is not the number of months or number of years, but it represents the number of payments. I say also that future value formula is used whenever the payments are made first and the total amount is accumulated later. This would include regular savings such as future purposes, for future purposes like education or holiday or retirement. So let's look at our first example. In this example, Hussein wants to save up money for an overseas vacation after he graduates from university. He opens a savings account and immediately, and this is something you must be really aware of, is when do we start with the payments. In this one, we start immediately and he deposits 500 Rand. After this, he continues to deposit 500 Rand at the end of each month for 4 years. The interest rate remains fixed at 80% per annum compounded monthly. So also something you need to take note of is if the payments are per month, then it is important to know that the interest must also be calculated monthly. It must always be the same. So if it's a quarterly payment, then interest must be calculated quarterly. The same for half yearly. So let's look at the first question. How much money will he have in the savings account at the end of the 4 years? So I think it is important that to start this question, that we first draw a timeline to see what is happening here. So this is our T0, this is T1, T2, and that is enough, and we go up to T48. I hope you agree with my 48 because it was 4 years. And of course, 4 times 12 gives us the 48. Now, it doesn't mean that n is 48. Remember what I said earlier, n is the number of payments. So every month, he will pay 500 Rand. But please take note, the first payment is at T0. That is immediately. And then from a month after, he continued to pay right up to the 4 years expire. So the big question with these problems are, what is n? Remember, n is the number of payments. So I hope you agree with me that N will be 48, the 48 months from T1 to T48, plus the one that we've made immediately, and that gives us 49 payments. Not all questions we will start paying immediately. In some of them, we only start after a month. And in our future sessions, you will also see when we start even later with our first payments. So interest rate is 8% per annum, and it's compounded monthly. So we can say I is equal to that 8%. If we take it to a decimal, it's 0.08. And we must put it over 12 because it's a monthly payment. The formula for future value is F equal to X, and X represents your monthly payment. So I can also write it down here that our X is 500 Rand. That is the monthly payment. 1 plus I to the N minus 1 over I. And now we just substitute. The X is 500. Then 1 plus my I, 0.08 over 12, to the exponent of 49, please not 48, minus 1 over 0.08 over 12. So now you just put this onto your calculator. Please use your fraction buttons. You don't need to give any more steps here. You can just put the whole thing on your calculator and just write down the final answer. Please try to make sure that you know how to put this onto your calculator, how to use your different keys, and check if you get my answer. I've got 28,862 Rand and 79 cents. So this is what he saved over the 4-year period. So he started immediately. So he made 49 payments, 500 Rand a month, and after the 4 years, the fund will be 28,862.79. Let's now look at the B part of the same question. In this one, we read that at the end of the 4 years, Hussein stops making payments. He leaves the money in the account for another 2 years while he completes a postgraduate degree. How much money will he have in the account at the end of these 2 years? So what is different in this question? And this is that there are no more payments here. No more payments. So he made all the payments. So that means that future value amount of 28,862 Rand 79 cents, that is what he will invest now for a period of 2 years. Please take note, no more payments. And if there are no more payments, it's not an annuity anymore. It's now just a simple problem on compound interest where we invest this money for 2 years at the same interest rate that was given to us in the A part. So we're going to use A equal to P 1 plus I to the N. A is what we want to calculate. P is the amount that he now saved over the 4 years, and it's 1 plus 0.08 over 12. Remember, the interest is calculated monthly. So we want to know the 2 years, you will hopefully agree with me, is 24 months. And now it's a simple calculation on your calculator. Put all of it on your calculator at once, and the answer you're supposed to get is 33,852 Rand and 82 cents. So that is what his money will be worth after a further 2 years. Remember, in A, we worked out what he will save over 4 years with monthly payments of 500 Rand. Then he left the money in the account, don't make any more payments, and that money will grow over the 2 years, and that is 24 months, to an amount of 33,852 Rand 82 cents. So let's look at our second example. Megan wants to save up 1 million Rand by her 30th birthday. On her 18th birthday, she opens a savings account to save for this goal. She makes equal monthly payments into the account starting 1 month after the account was opened. So first of all, please take note that she only starts to pay 1 month after opening the account. The last payment is made on her 30th birthday, and the account pays interest at 15% per annum compounded monthly. How much money will she have to save each month to reach her goal by her 30th birthday? So it's important that you realize that what they ask us is to find X in our future value annuity formula. How much money will she have to save each month? Now, secondly, she opened the account on her 18th birthday, and she wanted to take it up to her 30th birthday, which you hopefully agree equals 12 years. So N will be 12 years times by 12, because this is monthly. And that will give us an N of 144. Please take note, in this particular problem, it's not +1 like in the previous one, because she didn't make the first payment immediately. She only started 1 month after the account was opened. So if I can just quickly show you a timeline that represents this information. This is our T0, T1, T2, T3, and this will be T144. So the payments will be X and X and X and up to that one. So that is the payments for the 144. Our interest rate is at 15%. So 0.15, that's now if I take 15% to a decimal number, and I divide it by 12 because it is compounded monthly. So now for our future value formula again, 1 plus I to the n minus 1 over I. And now we substitute. You will also hopefully agree that F was given to us, the future value. And that was the 1 million Rand that she wants to save. So I substitute F with 1 million. X we don't know. And then I say 1 plus my I, 0.15 over 12. Exponent is 144 minus 1, and that is over 0.15 over 12. And now we want to solve for X. Please be very careful with your calculations here. The best thing to do is to first manipulate this equation and to find X. So I will multiply both sides with this fraction, and I'm going to divide with this whole big bracket, and that will leave us with X. So I hope you will agree that X is equal to the 1 million times by 0.15 over 12. This is now this part below the line. Divide by that whole bracket next to X. So that is 1 plus 0.15 over 12. Exponent 144 minus 1 over that. And now you put this onto your calculator. The whole thing, use your fraction buttons so that you don't make any mistakes, and then you can find your answer straight away. Please make sure that you do this on your calculator to get used to it. And the answer you're supposed to get is 2,508 Rand and 77 cents. So I hope you can see the difference between this question and the previous one. The previous one, we wanted to work out the future value. Now we know what we want to save, and we want to know how long, what the monthly payment will be if we do it over the 12-year period that is given to us. In the next example, I want to discuss with you still the future value, but now to find N. Let's read it. Linda wants to save up 30,000 to buy a new gaming laptop. She can afford to save 3,000 every 6 months. So please take note that the payments are every 6 months. So that means half yearly. So that means our interest must also be calculated half yearly. Interest is calculated at 10.2% per annum, compounded semi-annually. And you can see what I said earlier, that must always be the same. If the payments are half yearly, the interest must be calculated half yearly. How many payments? How many payments? And that, of course, is N. Will she have to make to have at least, and I will later on come back to that, at least the 30,000 Rand in savings. So let's first of all see what is given to us. First of all, F is given to us. She wants to save at least 30,000 Rand. I, we can find, because we take the 10.2 to a decimal number, which is 0.102, and now we divide by 2. Please take note, not by 12. Sometimes we get in a habit because most of these problems are monthly, and then we always want to divide by 12. Remember, this is semi-annually, only 2. And then we want to know what is N, how many payments she's supposed to make to get to that goal of 30,000. So my future value formula, once again, X bracket 1 plus I to the N minus 1 over I. And now we substitute. My F is 30,000. X is what we want to know. No, sorry, X was given to us. That was, sorry, for 3,000. I almost missed that. So our X is 3,000 Rand. So she will pay monthly 3,000 Rand. Her aim is to get to 30,000. So I say that is 3,000, 1 plus my I, which is 0.102 over 2. And the exponent is, I just want to make this a little bit more neat, 102. And then my exponent, like we said, in this case is N, that is the number of payments that we are looking for, minus 1 over my I, which is 0.102 divided by 2. Now it is quite important to notice what we will do next. We want to get to this bracket to the N, because we want to solve N similar way we did in the first lesson. So we're going to multiply both sides with a fraction. We're going to divide both sides with the 3,000. And then that minus 1, we will take it across, and that will leave us with the bracket on its own. So if I can just write it down for you. So I will say 30,000 times 0.102 over 2, and that I'm going to divide with 3,000. We're finally going to say plus 1 year, and then we will have the bracket. And that bracket, we can simplify the inside. You can use your calculator to do that. And you will get 1051 over 1,000. So that is my bracket to the N. Remember, we're going to use logs like we did in the first lesson. So now just to simplify this whole thing on your calculator, and your answer for this is 151 over 100 is equal to 1051 over 1000 to the n. And now with our log definition, we can find n, and n is equal to the log of, always this one, and that is 151 over 100, and my base is this one. So that is the 1051 over 1000. So it's n is equal to the log of this, base of that. Now you put that onto your calculator, the whole thing, you have a log button, and you will get to an answer of 8,28. Now what does it mean? This means that she must make a little bit more than 8 payments. So if she's only going to make 8 payments, you hopefully agree she will not get to the 30,000 that she wants to save. So that means she must do more payments. And that is why the question, you can see it said at least 30,000. So she's even happy if she saves a little bit more. So what do you think? How many payments are she supposed to make? And I hope you agree she must make 9 payments. So with 9 payments, she will have more than 30,000, which is fine because we want at least the 30,000 after that period of time. So that's my final answer for this question. I hope I see you again for our next lesson on the present value annuity.